So coalesce, a little bit about us. We've got deep knowledge of ColdFusion. We deal with a lot of high compliant environments, HIPAA, PCI, for example. We're the Adobe preferred vendor for migrating workloads to AWS, and we've been working on ColdFusion since CF6. So we've been around for a little while. All right, and today I'm going to go over a variety of things. We're going to get started with CFJava and AWS SDK to make sure you have some understanding of what it means and what it is. Then we're going to continue to the SSM parameter store, the secrets manager, the key management service, some CloudWatch metrics, and conclude with Q&A if that's even available right now. But we'll go ahead and move forward. So I want to start with the cloud native features that are in ColdFusion 2021. I'm not going to go over these, but I'll go ahead and at least put that out there so you know what they are. So that is storage with S3, the NoSQL databases with DynamoDB or MongoDB. You have message queues with Amazon SQS, and you have message delivery, which is SQS and SNS. And you can use all those without any third-party SDKs, which is a great part of the ColdFusion 2021 release. And as a prerequisite, I want to go over what you need to get started with the SDK. First, you need to create your AWS account. Second, you need to create your user profile that you're going to use to access those AWS services. And last, go ahead and download the AWS SDK for Java version 1. And I'll specify you need version 1 because version 2 actually requires you to use Maven to compile it, which is great if you need to reduce your memory footprint of your application, but not if you want to have this thing up and running very quickly. So the version 1 SDK is the full SDK for all of AWS services, while version 2 you can compile down to just what you need. And I'm not going to go into the version 2 because that'd be a completely separate presentation to talk about that. All right. Once you have the SDK, you need to get it loaded into the ColdFusion class path. That's the first option. And the easiest way to do that is when you unzip the SDK file, you're going to copy the SDK jar to your CFusion lib. The third-party lib folder has a number of jars that are dependencies of that jar. So you're going to put those in your lib folder as well. Then when you start ColdFusion, it's all going to be loaded to memory. Another option, which is the one I prefer, is to use the application.cfc.java loader. In that case, you're going to add a this.java settings to your application.cfc, where you give the path to the jars and whether or not you want it to reload on change. And that's all you need to do. One of the things I want to specify is I'm not going to tell you how to manually log in with basically a username and password to IAM. I'm only going to go over the methods that do not permit you to put your credentials directly into your code. Because overall, the end goal is having a secure, flexible code base rather than one that you need to be fearful of who gets access to it. So that's kind of the goal for today. So I'm not going to give you the inline directly in code methods. So you do have a number of options to do this. I'm going to start with the first one. If you're running on AWS compute hardware, you can assign an instance role, a task role, or an execution role. And in those cases, the AWS SDK will automatically know which role you're using and just use that credential automatically. So you don't have to do anything in your configuration. You don't have to put any extra credentials anywhere. It just works. Second option here, we've got the Java Systems properties. In this case, you can add to your JVM arguments the -d, AWS access key ID, and the secret key into your JVM args. When you do that and start ColdFusion, the AWS SDK will automatically see those and use those credentials. You also have the option of using your credentials file. So if you have set up a service to run your ColdFusion service, so for example, you have a ColdFusion user account on your local machine that you run your ColdFusion service under, you can create a credentials file in that user account's home folder and the AWS SDK will automatically read that credentials file and just use it. And the last option here on this page is environment variables. So you can set an environment variable, and the SDK will see that and use those environment variables. Overall, none of those are very difficult. I prefer the on AWS compute hardware, number one. But secondly, I like the JVM arguments. All right, so in case you've not used the new CFJava option in ColdFusion 2021, I'm going to give an example here. In this case, in the past, if you've ever used Java within ColdFusion, you've done a number of create object, Java, and then having to work with the Java types and so on and so forth. And that can be a bit cumbersome. The great part of ColdFusion 2021 is they made it very easy for us to use this. So in this case, the tag-based version at the top, you've got your raw Java code within the CFJava, and everything within there you can now access those that are public with normal ColdFusion access types like this. With the CF script version of this, it's this method here. Instead of CFJava, it's just a Java open brace and then your Java code. So typically what I do is I just copy paste the Java code I want, drop it in, and it magically works. Now you may have to tweak things here or there, but it's not nearly as complicated as it has been in the past. All right, this complicated page is just to give you an idea of the patterns in which AWS SDK operates. And in this, you start with a client. And you start with the client builder. The builder is what you use to build, and you get your authenticated client back. So you start with the builder, build it, you get your client, and from there you can call parameters. In this example, I have a get parameter and put parameter. And I have another request object I pass to this get parameter, and I get the result back. And it's another object. Same thing for the put parameter. The put parameter has its own request objects it needs that I pass to the put parameter, and I get the put parameter result back. What the overall goal of me providing this page is that once you've made one client build request process work, it's very easy to get the next process to work. And the first challenge is attainable, and once you attain that, then the next ones become very easier. And I put this little quote down here from the Word document for AWS SDK, and I can't read all of it because this little screen on top, but I'll move forward. The service clients, so the authenticated clients, are thread safe, and for best performance, you should treat them as long-lived objects. Each client has its own connection pool, and explicitly disconnect when you're no longer needed to avoid resource leaks. So you can create this once as you start your application, or once as you start a long group of objects you're going to be using within your program. Don't create it and connect every time you access a function. Create it once and then use it as many times as you can before you finish. And I'll give an example of this, of what I realized the first time I interacted with AWS SDK. I was writing a lot of records into DynamoDB, which is supposed to be blazing fast. And for some reason, it was taking upwards of, I believe, like 0.8 seconds to write a record, which was okay, but not great. But when I had to write thousands of them, this was taking an unbelievable amount of time. And it ended up being, I was not following directions. I was creating a new client for every time I was writing a record, which means it was authenticated with AWS, was doing a number of extra handshakes, and it just was not necessary. As soon as I started caching the client and reusing that client, I believe I was down to low double-digit millisecond time again. So don't do what I did. Don't create unnecessary clients and authentications, and make your life a whole lot easier and make your process run much faster. All right, so for the first module that I'm going to go over is the AWS Systems Manager module. And the specific part I'm going to go over is the parameter store. And this is a great way for you to store your configurations, secrets, anything that can be stored as a string of some sort. That's what we're going over first. So I'm going to start with breaking out to a demo. Hopefully everybody can see my screen still. All right, so in the AWS SSM module I have here, you can see, so this is in CF script, create a component in CF script, and the first function we have here is get client, and where we're passing the region. So every single one of these modules, we're going to be passing a region because AWS needs to know where we are trying to access their services from. So in this case, we're going to get client, pass the region, and then we're going to call this Java set of code here. And in this, we have the client builder that we are going to be utilizing to make the actual authentication. We've got a number of functions here, including get parameter and put parameter. And I'm not going to go into in depth of what each one does. It's not overly complicated, but overall, when you have get parameter, you create your get parameter request, and you store what parameter you're getting, and you tell it that you want to decrypt it if it's encrypted. And from there, you actually call it, get the results back, and we're returning it automatically as a string in this Java program here. Overall, the whole idea is we can take all of these lines of codes and access with very little amount of effort, and you'll see that when I actually use it. The other function is put parameter. In that case, we're going to give it a parameter name. We're going to tell it to override it. We're going to tell it a secure string, which why not? It means it's going to be encrypted within AWS. And we're going to pass the value it's going to store. So that's the module. It's not very long. It's not very complicated. And here's how easy it is to use it. So in the CFM page, we're going to get the client. We're going to pass the region US East 1, which is in Virginia. This is where I have it stored. In this case, we're going to go ahead and put a parameter called demo parameter. And we're going to put in there, this is my new parameter with the current time. And then we're going to immediately go and fetch it and pull it out. So you can see that we can take the 50 lines or so of Java code and knock it down to really 2 to put it and another 1 to get. So let's go test this out. What can go wrong? We're showing it live, right? All right, so it is the parameter store. So the parameter store just made a client connection to AWS. It wrote a new parameter, overwrote the one that was there, put the current time, which is 11:13 my time, which is correct, and then got it and dumped it back to the screen, which is what we're seeing here. Here we go. So parameter store is very easy to use once you have that module in place, and that's a very simple way to show how it works. So let's talk a little bit about why you want to use it. So you can store environment variables. So let's say you have multiple AWS accounts. You can have an environment variable called environment. One says prod. Another account that says dev or staging or sandbox, something. So you can store information about your environment in the parameter store. Credentials. So let's say you have credentials for some product you're connecting to or your database. You can store that in parameter store. So you don't have to have all these things stored in your code or pre-configure all your servers. You can have it configured on the fly, that sort of thing. Endpoints, if you have a endpoint specific to a different environment, you can store that in there, client keys, so on and so forth. Basically, the way I say it is anything you want to be exposed publicly in case your code gets exposed, store it in parameter store. The next one I'm going to talk about is the secrets manager. And I'm bringing this up because it's kind of the parameter store on steroids. It's a little bit more, it's the same line of thought, but it's got a little extra bits to it. And I'm going to jump into real quick how easy it is to use. And what I have provided in here is only the get. So I did not provide a method to put the secret. I only provide you a way to get it. And we actually reuse the parameter store parameters to get secrets. And all it is basically a parameter with a predefined prefix to the parameter name. And it may not make sense just yet, but I'm going to keep moving forward. So in this case, it's just the exact same way of pulling parameter, but instead we call it get secret. And again, 2 lines. We're going to create the client, make the authentication, and we're going to get our secret called super secret. In this case, I've already created the secret in Secrets Manager, and we're going to go pull it and make it display on the screen. And there we go. So in this case, my super secret is a JSON string, and it's called my secret with it's not so secret anymore, because I just showed everybody how it works. So in this circumstance, Secrets Manager is just like Parameter Store, but I'm going to go into what's a little bit different about Secrets Manager. So Secrets Manager is a higher level of compliance method of storing secrets. It costs a little more than Parameter Store, but it has some extra features if you choose to enable it. The big one is automating rotation of the secret on a schedule. And really, that's the only one I'm going to talk about. So the Secrets Manager has already direct integrations to AWS services. So for example, it's got a direct integration to Amazon RDS. So let's say your MySQL database has a username called admin with a predefined password that's generated. You can set it to automatically rotate every 3 months and replace the password on that username automatically, and the AWS Secrets Manager will automatically change your database password. Now, you do need to write a Lambda or some other method to call within Secrets Manager to tell your ColdFusion to refresh or retry or something. But the whole idea is Secrets Manager lets you have a defined rotation schedule to meet some compliance requirements. And otherwise, it acts just like a parameter store. All right, so speaking of compliance, we're going to jump into the AWS Key Management Service. So this is a secure and resilient service that uses hardware security modules to protect your encryption keys and provide encryption decryption functionality. So basically, the key point here is hardware key management. If you have high-level compliance requirements, you'll be recommended to try this out. So we've got 2 examples of how to use KMS. We have a simple way and we have a more complicated way. So we're going to start with the simple. In this case, we have a KMS key within AWS KMS, and we're going to encrypt and decrypt based on that AWS KMS key. The great thing about using KMS for encryption is every single encrypt action automatically goes into your CloudTrail logs. So if there is an encrypt, if there's a decrypt, there's a log for it. So if you ever have concern of whether or not your key got exposed or some data got decrypted, you will be able to tell because you cannot change CloudTrail logs. Let's go into an example of how that works. All right, so back into the KMS component file, we have this similar get client method here. We have the Java procedures, we have the client builder. The 2 main functions we have are encrypt and decrypt for this circumstance. And I'm not going to go into all these just yet because some of these are used in the more complicated one. But in the end, you can see here there's 20 lines of code, encrypt and decrypt, and a number of supporting functions at the end that let me deal with some of the headache of making this work for you. Don't try to figure this all out yourself because I had fun with encoding and decoding base 64 and all that sort of thing. So KMS1, we'll step through this. We've got our KMS client, and we actually ended up using the SSM client to store our KMS key. So we kind of blended the two modules here for this one. In this case, we store the KMS key in the parameter store so that we don't have to have our raw key AWS reference number baked into it. So instead of using get parameter, we could have just done key ARN equals and this long string as an example. But instead, we stored it there so we can quickly change it and view it within the AWS console rather than changing code every time we had to work on something. So in this case, we want to encrypt the quick brown fox, jumps over lazy dog. We output it just to make sure we display the screen. We encrypt it, output the ciphertext to show you that it is encrypted, and then we decrypt it and output the resulting plain text. So we should see the string, gobbledygook, and then the string again if everything worked. So let's go try it out. And here we go. There's our string. Here is the ciphertext, which is quite long. And then the decrypted string again. So it worked. So this shows a very good example of using KMS to encrypt a string. All right, so let's go to the more complicated version of this. In this, I need to introduce a few concepts. You have the data key. This first box represents the generate data key process. Excuse me. And in this, the AWS KMS will generate a data key for us that we then end up using to encrypt ourselves. And that's what this middle box is. We will take the data key provided and what we want to encrypt, and we will encrypt it locally, and then thus we have our new encrypted ciphertext. And when we want to use the encrypted key again in the future, we're going to have to decrypt the one we stored and then utilize that to get our data key back to be able to use in the future. And I know this can be very complicated, and I did not probably explain it very well, but hopefully as I go into the example, some of this will make more sense. So another thing I want to introduce here is the idea of encryption context. This is an optional set of key pairs used for additional context information about the data. So in this case, the way I word this is encryption context is a structure of information that makes sense to you operationally. So let's say that you encrypt some kind of PII, a personal identifiable information, and you will use your customer's ID in your system as part of the encryption context that you store that PII. So if you need to decrypt that PII in the future, you not only need the data key, which needs the KMS key, you also need to know the operational encryption context to be able to get access to that raw data. So it ends up creating more data points that some nefarious actor may have access to only one or two of those, but they likely won't have access to all three. So the encryption context gives you a bit more breadth to your encryption extent, and may have more compliance requirements to use additional authenticated data during your encryption. So that's how you can do it. All right, so I told you it's more complicated. Let's kind of walk through this as best as we can. KMS has access to your key, and it also outputs to logs just like before. We're going to generate the data key, and from that we're going to get two versions of it. We're going to get an encrypted version of it and a plain text version of it. In this case, the plain text is what we're using immediately to do an action. So in this case, we'll encrypt the PII, and then we will store that encrypted value somewhere. Now, later on in the future, if we need to decrypt that PII and PII, I mean personal identifiable information. So we will, if you want to decrypt that information, when we generated the data key originally, we were going to store it in the database so we can retrieve it later. In this case, in the later, once we retrieve it, we need to decrypt it. And we need to use AWS KMS to decrypt that data key. Once we decrypt it, we get the plain text back, and there we can use our decryption methods. So this is kind of the loop in terms of how you use the generate data key. And let's go over the demo for this one. All right, so similar process for the beginning. We have our KMS client. We have our SSM client. We have the key we stored in the parameter store. We're going to encrypt this string again. We have our encryption context, which in this case, I made up to be some tenant ID with a transaction ID. So if this doesn't match, I can't decrypt, is the overall goal. All right, so we're going to get our data key. So we're going to generate data key for our key that we have stored in the parameter store, and we're going to pass that encryption context we just created. And from that, we're going to get a structure. The structure is going to have both the plain text and the encrypted version. And here we're going to output the plain text version of it. Now, we're going to use the ColdFusion's built-in encrypt function to do the encryption now with that data key we received back. And we're going to output the ciphertext. We're going to then act like there's a break in this thought process here. And we're going to start with the ciphertext of the data key. So we're going to act like we store this in a database, and we're going to use it in the future to then try to decrypt that data again. So we're going to use KMS to decrypt that data key, passing the original encryption context we used to create it. And we're going to get that back. We're going to output it to the screen. And then we're going to use that decrypted key to then decrypt the string we did earlier. Sorry, where is it? Yeah, sorry. We're going to use that decrypted key to then decrypt the ciphertext we did locally in ColdFusion. So similar kind of flow, encrypt and later decrypt, but we've added a bunch of things in between. So let's see how that works. All right. So we first did the generate data key. This is what the plain text looks like for that data key. And then we encrypted, and then we have the cipher for the demo string here. And then we decrypted the data key later on, which thank God it matches, otherwise it wouldn't work. And then we decrypted the string that we previously encrypted. So we demonstrated generating data key, decrypting that data key, encrypting of a string, and then decrypting that string. That's a more complicated version of KMS. Hopefully somebody can find that useful. All right, so why would I use KMS instead of handling encryption myself? You have compliance requirements. You need to access log everything. If you need to rotate your keys, and you want to have options for high security encryption techniques, all those are available with KMS. And it's something I want to include here that I got from the documentation for KMS, speaking to what they recommend. They provide their own encrypt and decrypt keys, methods, and those methods are meant for encrypting and decrypting their data keys. They cannot accept more than 4 kilobytes of data. You might use them for encrypting small amounts of things such as passwords or RSA keys, but they're not designed to encrypt all of your application data. So you can use KMS's encrypt and decrypt for your applications, but it's not what they recommend. Just want to throw that out there. All right, so for the last module I'm going to go over is working with CloudWatch metrics. Amazon CloudWatch is a is a monitoring observability service that provides data and actionable insights and monitoring applications, systems, and resources. In a nutshell, that just means it's a place to store metrics and view the metrics on a graph of some sort. So I'm going to show you what this is, and then we'll talk more about it. So the module itself, similar fashion here, we have the get client, which has the builder, which generates for the region, and we have one function here, put metric. Now, put metric has things such as namespace, dimension name, dimension value, metric name, metric value, metric unit. I've done my best to make sense of this. You guys can use it in whichever way you want, but the way that I suggest using it, namespace could be your application name, dimension name could be your service name, the dimension value could be the measurement topic, and the metric name could be type of measurement. And you'll see an example of that in my CFM use as a demo. All right. So you see, it's not very hard to use the CloudWatch metrics. This metric is doing a random number of metric puts into this, but overall, the only thing required is creating the client. I'm defining those values. My app name, my service name is outgoing payments. My service topic is payment provider 1, and the metric that I'm measuring is the request time. So, for example, if I have a number of payment processors, I want to store how long it took for a payment to go through for each payment provider. So I'm going to create a custom metric for this tier of information in CloudWatch metrics. And in this, all I'm going to do is put each of those values in there and a random time, and the unit measure is seconds. And we'll see how this works. And there we go. It just added 18 measurements to CloudWatch. We'll refresh. It added 1. It added 4. So this is doing up to 20 random count of metrics is dropping into CloudWatch. And there you go. So let's go take a look, see what it ends up being in CloudWatch itself. So I ran this a few times before the presentation to have some data points in here. And you can see here that I've got 4 different items I'm graphing. I've got the average number of request time, the max, the min, and how many sample counts. And with this, you can see trends of, now this is not very pretty, but if you had more consistent traffic coming from an application, you can see those trends. But the overall goal is you can look back in time and see the performance of your application and how it makes sense to you. So in this case, I can see per payment provider the performance of how transactions were going in, and I can actually set alarms for each of these to go off if it hits some threshold. So CloudWatch metrics is great. The custom metrics is great for creating metrics that make sense for your system operationally. It does not have to be anything related to AWS infrastructure. It could be something specific that only makes sense to your application. And some examples for CloudWatch metrics, you can track your system load. You can send operational signals. So let's say that you had a catch of some sort, and you can say, hey, I hit an error at this time, and this was the value that was returned. And let's say it's some kind of measurement, not a string. You can send that through. And you also can configure metrics-based alarms. So if you had some kind of threshold that you were keeping an eye out for, you could use CloudWatch metrics to keep an eye out for that threshold. So before I conclude, I want to throw out there that if you could keep up with the CFCs that I quickly went through, you'll see that they followed a very consistent pattern. And that goes into what I said in the beginning, which is once you've got one AWS SDK service working, it's quite easy to move to second. And thus you have access to a large number of AWS services. And these are some example ones that I recommend you play around with if you have time. Recognition, comprehend, forecast, lex, extract, translate, transcribe, so on and so forth. There's a number of interesting things out there that I recommend you give a shot. So that's it for my presentation today. Thank you for attending. The code is out there in GitHub. It's github.com/solutions CFAWS. You can reach out to us at cf@ColdSolutions. See our home site. If you want to get ColdFusion running on AWS very quickly without having to pay upfront, you can go to AWS Marketplace, search for ColdS. You'll find our ColdFusion listings. And you can also go to getcoldfusion.com if you want to purchase a license directly from us.